Chapter 23, Example 3. Below are the mean weight gain and standard deviation from an experiment on pig diets. Use a confidence interval to discuss the results of the experiments. Both distributions are assumed to be normally distributed. Okay, so we want to discuss what we can see about these. Let's look at both diets separately and then together. So let mu of A be the mean weight gain on diet A. Let mu B be the mean weight gain on diet B. So of course, before we do anything, we need to check the conditions. The data was collected from an experiment. So it's reasonable to assume the data was from random samples. We are told both distributions are assumed to be normal. The conditions are met. I can use a student's t-model for the distributions. We'll state individually when we write it out what we're doing. We're doing t-intervals. So we'll start with diet A. Let the calculator do all the work for you. Find a confidence interval, just a t-interval. We're doing it from statistics. They're provided for us there in the table. So the mean weight gain was 55. The standard deviation is 3 pounds. And the number of pigs is 36. So there we go. It looks like we're 95% confident that the mean weight gain for diet A was between 53.98 and 56 pounds. So we're just going to record that interval for now. We'll go ahead and find the intervals of diet A and B first. We're also going to record that margin of error because that will come into play in a moment. Let's take a look at diet B now. Same thing, go to a confidence interval, a t-interval, statistics, plug in our information there from our box. So X bar is 53, standard deviation is 4, and sample size 36, 95% confidence interval. 95% confident that diet A weight gain is between 51.6 and 54.4 pounds. So we've looked at those individually, and it looks like their confidence intervals overlap. So maybe there's not a difference between the diets. Individually, the intervals of both diets overlap. So at first glance, it appears there is no evidence that there is a difference between the weight gain of the diets. So now let's look at the difference between diets A and diets B. Let's do this as a confidence interval with the difference of the two. So we're going to do a 2-sample t-interval from statistics. And same thing, x1 will be the mean for diet A, x2 the mean for diet B, so we plug all our data in there. And as usual, no pooled. Do not pool on means. So now let's look at it. Margin of error is 1.66, degree of freedom 64.9, difference is 2.3346 to 3.66. That's interesting. 0 is not in our interval. So, let's record that and then we'll discuss this a bit. So let's continue with our explanation down here at the end. So individually, both diets overlap. However, the confidence interval of mu A minus mu B shows that I am 95% confident that pigs eating diet A gain between 0.34 and 3.66 pounds. This would indicate that diet A is better for weight gain. So why does this happen? The difference in weight gain is smaller than the sum of the two separate margin of errors. We must sum variances to discuss the difference between two means. Variances add. We can't add margin of errors, which are a measure of spread. We have to add the variance together, find the standard error, and then calculate the new margin of error. You can't just add the margin of errors together separately.